Okay, first one, let's go. That first one is actually a bit of a tricky one, right? Because it doesn't have a y intercept like the other ones that we looked at. But also, guys, because there was no q value, the q value is actually 0, right? Which means that your horizontal asymptote was y equals 0. And guys, isn't that the x-axis? So if your asymptote is the x-axis, you also can't calculate an x-intercept. Right, so this graph was tricky in the sense that we couldn't actually calculate a point like we did with the other one. Normally we find the x-intercept and then we sub in another x value, depending on whether the x-intercept is positive or negative. But in this case, we couldn't find any points. So what did you have to do? You have to sub in a negative and a positive x value. So I decided to sub in -3 and +3 because if I subbed in -1 and +1, I would have had to plot something at 12 and -12, right? Which I didn't want to do. So that's why I decided to sub in -3 and +3. If you subbed in -1 and +1, like I said, you would have gotten -12 and +12 as those values. So you would have gotten -1, -12, and 1 +12, which is fine. Would have been very low and very high. So that's why I decided to sub in a bigger value so that those y values were a little bit smaller, a bit easier to plot.
X4, Y3, and then X3 is Y4.
Because you're dividing 12 by that much.
Is that like Y5?
All right, guys, are we fine with that one? Any questions? Your axis of symmetry, guys, I need to focus, please. The axis of symmetry, y equals x plus 0, right? Because our q value is 0, so just y equals x, and y equals -x. Yeah. No, unless they ask it as a separate question. They can ask in a question, write down all the equations of the axis. So no, if it's just a draw the graph, we just look at the graph. Equations of y equals 3. But then you would have to also sub in a negative and a positive one. Yeah, that's fine. So then you would have gotten 4 and 3 as a set, and then the 4. Yeah, that's right. Okay. So there is, but it's just the because the q value is our horizontal asymptote, and in this equation, the q value is 0. Right? So the horizontal axis has, or asymptote, sorry, has to be y equals 0, which is not. Well, a graph never has the asymptote. There's nothing to do with the x and y axis. It's a line that the graph never touches. So this, the hyperbole, not the Cartesian plane, the function of the function.
I think I thought it was like an asymptote that never touches the line.
No.
Oh, it was great. That's all I wanted.
Okay. Oh, I'm glad to hear that. I'm free. Guys, I would like you to write down, thank you. Please write down the domain and range of this graph underneath or next to it or wherever you have space. You don't need to know, that's why I'm asking you to do it now. There we go. So let's go back to the rendering. Order your responsible friend. Okay, I'll find that. That's the main range. So that's what. Yeah, and these are going to be the values of that. All right, let's look at the next one. So this one is a bit difficult to draw because the y asymptote was so far down. So I decided to use two blocks. Sorry, one block is 2 units on my y axis. Oh, sorry, this is E, guys. Sorry, E. Remember what we did as an example on 12 already. So this one is E. Oh, do you guys want to see the working? There we go. Let's look at that first. Sorry. Yeah. So, oh, it's minus 5, yeah, sorry, yeah. X minus 5 and X negative X minus 5. Yeah, sorry, I'll fix that now. I did draw them correctly and wrote the equations down wrong. No, not today, but obviously. Guys, know what you can do. Yes, I have to go to do that. Oh, I didn't label my points. Negative 2, negative 2. And 2, 0. Write down the domain and range of this one as well, please. On R. Look, I mean, I think I'm going to see. Okay, domain and range, there we go. There's the bottom. So for the domain again, all real numbers except for x equals 0, which is the y-axis. So that is the one asymptote. And then for y elements of real numbers equals negative 5. Yes, inverse. All right, if you guys are done there, you can write the next heading. So I'm finding the equation of a graph. That's what we're doing today. All right, thank you. Guys, you were gone for like a day and a half, and now we're back where we were. All right, I want us to write down the standard forms of these three graphs underneath their names. Because now we are going to be given any graph, and we need to first identify which type of graph it is, and then we need to know what is what, right? In the equation, what represents what kind of property of that graph. Right, a straight line, we know that that is y equals mx plus c, right? What is c, or what does c represent? The y-intercept. So guys, if they give you the equation of a straight line and the y-intercept is given on that, sorry, not equation, the graph of a straight line, and the y-intercept is shown on that graph, then you need to know that that is your c value. All right? M, we remember, is the gradient. M is not the x-intercept, guys. That is the most common mistake with these questions when it comes to straight lines. People think C is the y-intercept and M is the x-intercept. That is not the case. M is the gradient, which remember we can calculate by doing delta y over delta x. So if we have 2 points, you can calculate the value of the gradient by doing change in y over change in x. We did do an example of this on the first day when we did that. Take the y value of the 1 point minus the y value of the other over x value is the same, so the point minus x value. Okay, parabola, what is that standard form? Y equals ax squared plus q. What is q, guys? Y-intercept. You can call it q if you want to. It's q in it. Q is the y-intercept, just like with the straight line. Now guys, A, unfortunately, you can't work out what the value of A is like we did for the value of M with a straight line. There isn't a specific formula for the value of A, but what do we know about A? Yes, and if the graph looks like this, what kind of number is A going to be? Positive, right? So if A is positive, so we can at least tell that by looking at the graph. If A is positive, the graph is going to look like this. And if A is negative, then the graph is going to look like this. So you can tell what the sign of A has to be by looking at the graph. But yeah, I'll show you a method for calculating A when we're doing it. There isn't like a set formula to calculate that. Okay, for hyperbola, the standard form is y equals a over x plus q. Now guys, this is the odd one out because q is now not the y-intercept. Q is the y asymptote, if you want to call it that, right? The horizontal asymptote, y equals whatever. That is the q value. I'm just going to write here that the horizontal asymptote is y equals q. So guys, if they have that dotted line on the graph and they're telling you what the equation of that asymptote is, then that is your q value. Now, just like with the parabola, unfortunately, there is not a formula to calculate A. We are going to have to use a different method. But in the same way, we can look at where the graph lies to see whether A is going to be positive or negative, right? Can anyone remember what happens if A is positive? Yeah. Quadrant 1 and 3. Is that right? I actually always forget. Quadrants 1 and 3. But remember with that asymptote, the quadrants do shift. But you can at least figure out based on like their position, I suppose. You can see what your A value would have to be. And then for negative, it's going to be quadrants 2 and 4. All right, we're going to do an example of a parabola now so that you can see the method that we need to use to calculate A. It's going to be the same for hyperbola. Okay, so the method to calculate A is the same for both of these. Are there any questions on what we've written down so far? Okay, so example. It depends on how we do it. Jonathan, I'm not sure. Okay, we are going to have to draw a graph, unfortunately, but you don't have to draw it to scale. That's a parabola, guys, so you can draw the graphs along. Sorry, I'm just trying to get mine looking kind of okay. Mhm. Mhm. 16 is going to be in a few, but hang on. All right, parabola. What you guys done? Join us. Let me go to- Okay, Okay, so first thing, guys, and you often get a mark for actually doing this. You recognize that is a parabola, so you write the standard form of the parabola. Okay, it's almost like remembering a formula and writing it down. Sometimes you will get a mark for doing this, sometimes not. Depends on the case. But that's quite nice if you do get a mark for school, knowing what the standard form of the parabola is. All right, we said at the top that Q is the y-intercept. They have given us the y-intercept here, right? 16. So Q is not a good question, 16. Right? Isn't that a nice mark to get? There we go. Now guys, to calculate A, I suppose you could kind of do it by section if you understand that the 2 points that they've given you there are x-intercepts. And if you can kind of visualize what would the equation have to be so that when you solve, when you make y equal to 0, you get -4 and +4 as your two x-intercepts. You can kind of do it by section like that. But if you can't, which is fine, you don't have to. I'm going to show you a method now that will always work, all right? Firstly, what I want us to do is to just rewrite this equation and now to put 16 in its place. All right, so we're going to have y equals ax squared plus 16. And do we notice that a is going to have to be a negative number, right? Because it is a downward facing parabola. So we know that when we are solving for a, we're not getting a negative number, we've done something wrong. Okay, we can tell that immediately. A must be negative. Hang on. Now, guys, you are going to choose either one of these 2 points. We actually have more information than we need. You can choose the easiest point. Let's go with this one, 4, 0. And what I'm going to do is I'm going to substitute this point into the equation that I have now. Because what values do I have in this point? What is 4? 4 is an x value. So I can put the 4 in the place of x over there. And y is a, sorry, 0 is a y value. So I can put 0 in the place of y. Right? So I can make that 0, I can make that 4, and then I'm going to have an equation with just a as a variable. Okay, so I'm going to write here, sub in. And the important thing, guys, is you have to sub in a point that you have not used already, okay? So we use the y-intercept point to get our Q value. So we can't sub that point in again. You're going to end up with a 0 equals 0 to 20. All right, so you have to sub in a point that has not already used. Yes. Okay, so like I said, guys, you can sub in -40 or +40. It's going to give you the same equation in the end because what are we doing with the x value here? We are squaring it. So when you are subbing in -4 and you're squaring it, that's going to give you 16. And when you're subbing in 4 and you're squaring it, it's also gives. Okay, so I'm just going with 4, 0 because that's like the easiest one, but it really doesn't matter. So guys, what I want you to do, please, is to write the coordinates of the point that you are subbing in to show the marker what you're doing in case you're making a mistake somewhere. All right, so that we at least know what your thought process was. So I'm subbing it into that equation. All right, so what is my y value here? It is 0. So I'm going to replace y with 0. So 0 equals a times x squared, and the x value of this point is 4, and then squared, right? So it's x squared. Plus 16. So I'm going to say again, guys, the reason why I'm doing that is if I look at this equation, I have 3 variables. Y, A, and X. I can't possibly solve for A if I have 3 variables. So I'm subbing in a point that cancels out 2 of those variables, right? Turns those 2 variables into numbers. And here I am only left with 1 variable, which is A, which is what I still have to solve. All right, what is A times 4 squared? 16a. All right, you can do this all in one step. You can take that 16a across if you want, but that is basically what we end up with. So negative 16a equal to 16. So what is my a value? It's a 1. And we knew those were meant to be a negative number, right? So we know that we got that right. Okay, so therefore the equation is y equals negative 1x squared. So you can just write negative x squared plus 16. Guys, I would like you please to highlight where we wrote here, sub in a point that you have not already used. This is such a valuable method. We're going to keep using this method in AP and grade 11 and grade 12 when we're finding the equation of graphs and when we're just working with graphs in general. Often we're going to have to sub in a point. I think you might have done it in grade 9 with straight lines, subbing in a point in some cases. So definitely for that one, possibly for this one, but maybe not. You will get a mark for the substitution line, a mark for calculating A, and then a mark for the final answer. Okay, so that could be a 4 mark, maybe a 5 mark. All right, guys, with the hyperbola, it's going to be the exact same thing. You're going to get your Q value by looking at the asymptotes. And then to find A, you're going to sub in a point. All right, that's 12 way. I'm not going to do an example like that now. I want to give you guys a lot of time to work in class now. So you're just going to practice a whole bunch of these. Are there any questions on this, guys? Anything I want to make sure of before you do your own? No. Okay. So exercise. Okay. Yeah. The one. Would we put that in as yes. Yeah. Where am I now? Exercise 8.4. Page 117. Guys, this looks like a lot, but it's just each question is just one graph. They're not super complicated, and you still have half an hour. So I'm just gonna look at this. What the question was, I'm gonna check. All right, last one. Sorry, I had to choose out the ones that are not exponential graphs because we haven't done those yet. That's why it's a long list. Okay, we're going.